In this video, we're going to look at some theorems from College Algebra that will help us solve a couple of problems here. Now, one of them is called the Conjugate pairs theorem. The other one is called the Factor Theorem. And we know that if we have a polynomial with real coefficients of degree n, we expect at most n distinct zeros. Now, we could have some that are repeated. Okay, for example, it could be that we have polynomial degree 6, and all 6 zeros are 1. So it's 1 would be a 0 multiplicity 6. But here we're going to focus on these two. So the conjugate pairs theorem basically tells you that if you have a polynomial with real coefficients, and you know that a plus bi, this is the standard form of a complex number. A and b here are real numbers, and I is the imaginary unit. And of course, I is equal to the square root of -1. That's what makes it imaginary. Now notice that if b is 0, all we have is a, which is a real number. So we can say then that every real number is also a complex number. So this is a complex number here. But when b is 0, we get, so the set of real numbers is a subset of the set of complex numbers. So when we say a complex number, that could be 3, 1/2. That could be 1 plus I, 1 minus I. The complex numbers includes the set of real numbers. So basically what this theorem is telling us, the conjugate pairs theorem, if I know that a plus bi is a 0 of a particular polynomial with real coefficients, then the conjugate of that, which would be a minus bi, is also a 0. So if I know that I is a 0, that's the imaginary unit, pure imaginary, then I know then minus I is also a 0. Okay, that's assuming the polynomial has real coefficients. That's the key to this statement. So now from that, let's look at the first problem. It says find the remaining 2 zeros of a polynomial of degree 6 whose coefficients are real. Okay, so now again, coefficients are real. So we have 2 real zeros, 2 and -3, and then 2y and 1 minus 2y are zeros. Okay, based on the conjugate pairs theorem, if 2y is a 0, then 2y has to be a 0. The conjugate. Sorry, this should be minus 2y. 2y is a 0, then minus 2y has to be a 0. And again, if 1 minus 2y is a 0, then the conjugate of that, which would be 1 plus 2y, would also be 0. And that, of course, would be degree 6, because you got 1, 2, 3, 4 given, and then the 2 we found here using these conjugate pairs theorem gives us 6, and that's what we expect at most. Since it's degree 6, we expect at most 6 distinct zeros. So let's clear this. Let's go to the next one. So this one says find a polynomial of degree 5. Find a polynomial of degree 5 whose coefficients are real that has the zeros 0, -2y, 2 plus I. So in this one here, we're going to use the factor theorem as one part of the problem. And the factor theorem simply tells me if R is a 0 of a certain polynomial, let's call it polynomial p of x, then x minus r has to be a factor. That's all it says for the most part. So let's look at a basic example here. Let's say we're looking at the polynomial p of x is equal to x squared minus 9. So you should you should see here that if I replace the x by 3, 3 squared is 9, 9 minus 9 is 0. So 3 is a 0 of that polynomial. Put a negative 3 there, negative 3 squared is also 9 minus 9 will give me 0. So 3 and negative 3 are the zeros of that polynomial. Okay, so what the factor theorem tells me is if I know this part of it here, if I know that these are zeros, then I know that x minus the 0 is a factor. So x minus 3 would be a factor of that polynomial. And minus 3 is a 0, so x minus that value, which would be x minus a minus 3, which would be x plus 3. So if they give me the zeros, I should be able to find the polynomial. So here are the factors. I multiply that out, and I get x squared minus 9. So using the factor theorem there. Now let's clear this. Now let's go back to this one. Find a polynomial. So they give me the degree of the polynomial, which is 5. And the coefficients are real, so I can apply these theorems here, especially the conjugate pairs theorem. So this would go this way. So the polynomial, I'm going to call it P. You can call it anything you want, P of f of x. So let's write it out. They want the actual polynomial. They give me the 0. So 0 is a 0, so x minus 0 would be a factor. But x minus 0 is just x, so I'm just going to leave it as x. Then the other factor would be negative 2i is a 0, so x minus a negative 2i would be a factor. So you subtract that, and that gives you a positive 2i. Okay, x minus a minus 2i. But from the conjugate pairs theorem, because negative 2i is a 0, then I know the conjugate of that is a 0. So that would be 2i. So I know that 2i, not only negative 2i is a 0, but 2i is a 0. So the next factor would be x minus 2i. So I got this part. Okay. And then, okay, the next one is x plus, or 2 plus I is a 0. So x minus that has to be a factor. So that would be x minus, okay, so let's do this, minus that and minus that. So let's just put it as minus 2 minus I. Okay, so 2 plus I is a factor, so x minus that is or 2 plus I is a 0, I should say. So x minus the 2 plus I is a factor, so I get this. But again, from the conjugate pairs theorem, I know that if 2 plus I is a 0, then, and because it has real coefficients, 2 minus I is also a 0. So then I write over here, x minus that would be a 0. So I'll just put it this way, x minus, okay, so that'll give me a minus there for the 2, so that'll be minus 2. And then minus the minus I is a plus I. So we get this. All we have to do then, this is actually the answer. This is actually the answer, but they want it simplified here. You don't want to leave it with i's because you want to write it with real coefficients. So here's what we'll do. We have an x here equal to, okay, so this will be x, and then x plus 2i times x minus 2i. So that would be x squared. So notice I have the difference of the same two terms, x plus 2i and x minus 2i. So it'll just be the square of this, and then minus this product. So this will be minus, and then 2 times the 2i is 4i squared, 4i squared. But I squared, you should know, is a negative 1. So I can write this as a minus 4i squared, but then this becomes a plus, because that I squared equal to negative 1. Okay, so this becomes this. Notice no I here. Now in the other one, I've got this times this. So let's think of this as like a minus b times a plus b. A minus b times a plus b. So treat it like a binomial. Like a minus b times a plus b. It's a squared minus b squared. So in this case, that's going to give me a minus 2 squared. Okay, that's this one times this one, minus the product of the other two, I times I, that's I squared. And then what do we have here? So this is going to be, let's multiply here by the x. So this x times this is going to give us x to the third. And then x times 4x, or x times 4 rather, is x is plus 4x. And then in this one here, let's look at this part right here, x minus 2 squared. Let's do that over here. I'm going to do it over here. So that's going to be x squared minus 4x. Okay, I'm just squaring this using the formula for the square of a binomial. Be x squared minus 4x plus 4. And then here, I squared is negative 1. I squared is negative 1. So minus a negative 1 is a plus 1. So this becomes a plus 1. So to simplify this, then in the next parentheses, then I'll have x squared minus 4x. And 4 and 1 is 5. And now I've simplified it so that now I don't have any i's. Okay, so this could be the answer here. But your instructor might want more simplification here. So let's do this. I'm going to multiply through by the x cubed. So x cubed times x squared, that's x to the 5th. Okay, multiplying the second, or the second factor here, trinomial, by x to the 3rd. So that's going to be x to the 5th minus, then x to the 3rd times a minus 4x. Give us a minus 4 x to the 4th. And then x to the 3rd times the 5 is a plus 5 x to the 3rd. Okay, now I'm going to multiply by the 4x. Everything in that second parenthesis by 4x. So 4x times x to the 3rd. This will give me here, I'll put it into this term here because that's going to generate 4x to the 3rd. So I'll put it into this one. And then now 4x times a minus 4x there. 4x times a minus 4x is a minus 16. X squared plus, okay, and then 4x times a 5, that's going to give me a 20x. So then we can just add a few terms here. So the polynomial says find a polynomial of degree 5 whose coefficients are real that has the zeros 0, minus 2i, 2 plus I. Okay, so because this was given, we knew that 2i was also a 0. And also because we're given 2 plus I by the conjugate pair theorem, we knew that 2 minus I was a 0. So the answer to this one, in the simplest form we could give it here, would be p of x is equal to, and then we just write out the terms, x to the 5th minus 4x to the 4th Then here we just add these up. 9 x to the third minus 16 x squared plus 20 x. So this was find a polynomial of degree 5, like I said here. But see, this is just one. There are many that would satisfy this. If I put a parenthesis here and put a 10 out in front of this, this is still going to work. Okay, with these zeros, because any positive number or any number times 0 is going to give me 0. So it's going to satisfy. So I could put a 7 and say that's going to be one polynomial. I could put an 8 out in front. I could put 100 out in front. What they usually do is they put an a over here in front, or a k, and they say that's a constant. So if you want 1, you can choose a to be 1, and that what I got there would be an answer. If you want a different one, let a be 2, or let a be negative 2. So here a is any real number. So sometimes I just write it like that. Okay, that's the end of this video. I hope this helped you out. Thanks for watching. We'll see you next time.